This is the Smart Buildings Academy podcast with Phil Zito, episode 451. Hey, folks, Phil Zito here, and welcome to episode 451 of the Smart Buildings Academy podcast. In this episode, we're going to be talking about BACnet integrations. So we're going to be going through what BACnet is. We're going to go through the protocols, and then we're going to look at some integration fundamentals. So if you have been trying to figure out exactly how do I integrate with the BACnet system, whether that is part of a retrofit or part of an addition, this is going to be the episode for you. As always, everything will be available podcast.smartbuildingsacademy.com/451. Once again, that is podcast.smartbuildingsacademy.com/451. For those of you who are listening after the fact, there will be a visual component to this. So definitely check out that link and you'll be able to see the visual recording. If you find this valuable, the best thing you can do for us is to go on iTunes or Spotify, leave us a 5-star review. If you're watching on YouTube, hit the subscribe button and the notification bell. And if you're on LinkedIn or Facebook, please share this and comment. As always, this is an interactive live podcast, so feel free to ask any questions as we go through things. All right. So picture this, BACnet, right? BACnet is, by all standards, the de facto protocol for building automation. Let's define a couple terms before we get too far into this. A protocol is just a form, a standardization of communication and syntax and data structures and all of that. So if I say, cat ate the dog or dog ate the cat, those have completely different meanings based on which words I put in what order. If I put ate the dog cat, that doesn't really make a whole lot of sense. So protocols, they allow us to, one, go and structure communications, but they also allow us to define, like, what is a dog? What is a cat? And then we'll also say maybe it's a red-haired cat. Maybe it's a hairless cat. Maybe it is a, Doberman Pinscher dog. And so we are able to add descriptors, which are often called properties. And the actions these objects, the dog and the cat, can take are often known as services. They're the capabilities that these different objects can invoke upon one another. It's important that you understand this because as you start to do integrations, you're going to be working with a slew of different objects. The primary objects on a BACnet integration that you are going to work with are devices, inputs, outputs, and values. Now, on a previous episode, I believe it was episode 449, we discussed the difference between binary inputs, binary outputs, binary values, and then the same, right, for analog and multi-state. We called them both binary, analog, and multi-state. We also called them Boolean, numeric, and I think enumerated. That way, those of you who are from the Tritium world got to see that kind of description. But in the BACnet world, we are dealing with a slew of objects. There's dozens upon dozens of objects, but in reality, there's only a handful of objects you need to know. The first object, and this is where things get a little funky, so bear with me, because if you understand this concept, it's going to help you out a ton. The device that you're connecting to and integrating with, maybe it's a controller, maybe it is a sensor, maybe it's a supervisory device. The device you are connecting with is a device object. It is an object of the type device. Now, this is really important because all objects in BACnet have properties. And there are set properties, and we'll do this in a future episode where I actually dive deep into objects and we dive deep into properties and services. This is going to be kind of a cursory overview. But all objects have required and optional properties. Some of the required properties may be things like the object ID. That is going to be a required property. And you can find all of this in the BACnet 135 standard, which is freely available on the read-only ASHRAE standards page. If you Google ASHRAE read-only standards, you scroll down to standard 135 BACnet, you click on that, and you can read through the standard for BACnet, and you could discover which properties are required and which properties are optional. This is important for you to understand because in most integrations that I've worked with, there are two areas in which they fail from an integration perspective. First is that the object's properties are not properly configured or the protocol communication is not properly configured. We haven't got into protocol communication yet. We will. So objects, right? You have your device object, and when you go and discover devices, you build what's called a BACnet list of nodes. So a BACnet node on a network is typically a BACnet device object. Could be a sensor, but sensors are devices. I know it gets a little confusing. We'll clear this up more when we get into BTL listings, BACnet testing laboratory listings, a little bit later in the episode. But suffice to say, you have a BACnet object of type device that becomes a BACnet node when it is discovered. And then as you discover what objects are under the device, you will start to discover your points. So far we've said that when we discover a object, maybe for simplicity's sake, we're going to stick with a very simple object through this. We're going to talk about a application specific controller profile, of which will be a variable frequency drive. We're going to look at an ABB frequency drive point list a little bit later in the episode. But so for this, that is going to be our device object that we're discovering. And then we discover that using a service, which is called the whoisIam service. More on that later. And what will happen then, once we've discovered that object, that device object, and we've built out our BACnet node list, of which this ABB VFD drive is a BACnet node, then we do a whoisIhave discovery, which is a sub-object discovery. And we're going to discover the objects, which are binary inputs, binary outputs, binary values, analog inputs, etc. We're going to discover those. This is often called points, but in BACnet, they're called objects. But we are going to discover our points, and those are going to then populate under an array of points. Why do I tell you all this? Why does any of this crap matter? It matters because this is where things will fall apart. You have an improper setting on your MSTP bus speed, or you have an improper configuration of maybe duplicate device IDs, and then you're not able to run through these processes. So simply by understanding, oh, I'm discovering all my objects at the device level, but I'm not discovering them at, the binary input, binary output level, whatever, that starts to help you figure out where things are breaking. And you already saw me describe two services, the primary two services we're going to be using in integration, which are going to be our whoisIam, whoisIhave. Those are our primary discovery services, which then brings us up to our protocols. So to this point, you should have a pretty decent understanding of devices and objects at a high level, about 30,000 foot level. If you don't, please comment in the chat. I'll clarify anything. But now we move into our protocols. BACnet standard has multiple protocols. The protocols we care about Actually, I shouldn't call them protocols because BACnet itself is a standard and protocol. I should call them communication methodologies. I'd have to open the standard to see exactly what they call it. But you have BACnet over Internet Protocol or BACnet over Master Slave Token Passing, which is an RS-485 standard. So BACnet IP, Internet Protocol, this is a layer 4 protocol, meaning that it connects at layer 4 of the OSI model. It uses UDP, User Datagram Protocol, which means it's a connectionless protocol. And that is something we'll probably talk about in a future episode, but it uses what is called a BACnet virtual link. And so these virtual links are created between devices that are communicating. Why is this important? This is important because that virtual link allows a device like the ABB drive we're going to be integrating with to tie into maybe a Niagara supervisor or an SNE at Johnson Controls supervisor, whatever. It allows you to go and do that integration. When you are setting up a protocol, there's very specific things you need to set on the protocol and enable to ensure integration. Let's first start with MSTP and then we'll go to IP. With MSTP, we have to understand that BACnet MSTP follows the RS-485 standard, and it supports 2 baud rates if it goes, and by default, it has to support these 2 baud rates to be adherent to the BACnet MSTP standard. It can support more baud rates. So for those of you who are like, there's more than just 2, you're absolutely right. But by the standard, it has to support 2, 9600 baud and 38.6. If I remember correctly, I think it's 38.6. It may be like 36.8, but I'm fairly certain it's 38.6. Don't memorize something you can Google, folks. But it has to support those 2 baud rates. Baud rate is the communication speed at which the device communicates. If you have mismatched baud rates on your network, you can have everything from no communication at all to intermittent communication. Next thing up, okay, we've got our baud rate. Then we have to make sure that all of our wires match up. So we have to have positive polarity across our trunks and negative polarity across our trunks. We have to make sure that our reference wire, if we're using one, is properly terminated and our shield is properly terminated. I don't want to terminate both sides of the shield. That turns it into an antenna. We also want to adhere to RS-485 standards of segment length, how many nodes can be on a segment, which we'll talk about RS-485 in a future episode. Assuming all of that's done, then we have to go and set up the unique IDs and MAC addresses of our devices. Each device, if it is a master device and not a slave device, so a slave device would be something like if you're mapping in a sensor, whereas a master device is going to be one that can initiate service calls, whereas a slave device can only respond to service calls. So a master device can initiate a read property or a write property, whereas a slave device can only respond to the read property or write property service. So the master devices are going to be between 1 to 127 MAC address. So it's really important that the first thing is on our trunk segment, we have unique MAC addresses. So an address of 1 through 127 if they're master devices. Now, another key point here is ideally you want those addresses to be sequential from the start of the line. I get if the supervisor is in the middle of the trunk, that may not be possible, but ideally you want to have them sequential, especially if you're at lower baud rates, because how a token works is the first MAC address gets the token, then the second gets the token, and you need the token in order to invoke service calls like write property, read property, etc. So it just makes your trunk a little bit faster if you have sequential addressing. So you have a unique MAC address. Now you need a unique device ID because the BACnet node address for a MSTP device is device ID plus MAC address, and that equals the BACnet address. That is why you can have a MAC address 4 and device ID 4 on one trunk, and then in another building on a separate trunk, you can also have device ID 4 and MAC address 4 because those are two addresses, but they're on trunks. They're on an isolated context. When you get to IP, what you're going to realize is you can't do that. And that's one of the things that throws a lot of people for a loop is they'll have a device ID in IP and they'll be like, oh, but I could have a device ID on my MSTP trunk here and my MSTP trunk here, and they didn't have to be unique. And you also see this with points, by the way. But then as soon as they get to IP, which has more of a global context, you'll start to run into issues. I will tell you, though, sometimes you cannot have unique device IDs on MSTP devices. We're not going to get into those use cases, but there are some cases where that becomes an issue as well. So all of that being said, we then want to move to our IP. So that's MSTP. And we move to IP. IP integrations is where things get a little bit more complex because you start to have subnets, BBMDs, BDTs, so BACnet broadcast management devices, BACnet distribution tables, and you start to have all sorts of IP aspects to things. I think we'll do IP in a separate episode just because there's some IT networking concepts that you need to understand. Mainly, you need to understand subnets. You need to understand routing. You need to understand those kind of concepts. What's a unicast versus a multicast versus a broadcast message? And we're already at 17 minutes, so that would really kind of take us down a rabbit hole. So we'll stick with MSTP for this integration. So I'm going to go and I'm going to share on my screen real quickly. And by the way, if you have any questions so far, just feel free to ask. So let me go to share screen, window, BACnet's points list. And let's bring this up on the screen. And I'm going to zoom in here. And this is where things are going to get a little squirrely. Because if you went through episode 449 with us, you remember me telling you that inputs are not writable. And that is true to a point. But what you'll notice is that while inputs are not writable at the present value property, they are writable at certain other properties, like the out of service or the object name or various other things like our COV increments, change of value increments. So this becomes important for us because as you go into certain integrations, you may have to go and configure certain things in the integration, namely things like object name, namely things like a out of service value. So if the sensor fails, what value does it share so that potentially the system keeps running? So what we have here, and we're going to start at the very top, is first we have a BACnet standardized device profile, BACnet application specific controllers. Now, without going too far down the the BTL profile listings, which you can, by the way, you can find at the BTL website or you can find in the ASHRAE 135 standard. Essentially to say, BACnet, when someone builds BACnet devices, and all BACnet devices are a set of source code put in an embedded device. So when they build a device and they get it certified as being BACnet compliant, they need to certify it against a device profile. And a device profile consists of a series of BIBs or BACnet interoperability building blocks. And each bib, as you can see, is going to have a series of capabilities. And you will see A and you will see B. Don't quote me on this. If I remember correctly, B is server and A is client. I may be backwards. But suffice to say, you'll see data sharing, read property, data sharing, read property multiple, data sharing, write property multiple, data sharing, COV. So sharing data based on the change of value. So what it's saying is this device as an application specific controller supports read property and read property multiple, meaning you can read multiple points at the same time or you can read points. I'm pretty sure this is client actually because it's not able. No, it's server. That's right. This is a freaking confusing thing about BACnet here is that clients can invoke services, but servers serve results from services. If I'm remembering this correctly, I may have it mixed up. I'd have to Google it. I do know that clients can invoke services and servers serve up services. So don't think client server as in like a server machine, but rather just a functionality. But I don't remember if B is server or client. I'm actually now starting to think B is server. I'm digressing. I'm going down a rabbit hole that doesn't really matter to you. But suffice to say, it can respond to read properties. It can respond to write properties. Dynamic object binding. This is more of like how you build things out. When I was talking about discoveries and object nodes and BACnet arrays and all that, reinitializing device, time synchronization. So if you wanted to sync the device time, etc., communication control, all that jazz. But these are the bibs that this profile supports. You can learn a lot more about this by going and looking up BTL listing. But to this point, right, we've gone and we've found our device. We found our description of the device. We know what it supports, what profile it is, what protocols it supports, right? Let's be real. You're mainly just going to see BACnet IP, Annex J, not typically foreign device, but just typically BACnet IP or MSTP. Like I said, master, slave. It supports both, which means that you could make this a slave device and it would just respond, but it wouldn't initiate. Or you can map it in at the master class, but it's still not going to initiate. It's just going to respond. And we keep going. It's not a secure device because it's not BACnet secure. That doesn't mean it's insecure. I do want to eliminate that belief. All right, so we see the different object types. We see what properties it supports, and then we're going to go further, and we're going to start to see, actually, if I get past all this crap, because I don't want to go into their specifics. Bear with me, folks. I apologize. The scrolling makes me feel nauseous, so I can only imagine how it makes you feel. But right here, we can start to see our BVs. Remember, our BVs are commandable / writable. I do want to get to a nuance of language that is specific to BACnet. You're going to see read-only, writable, commandable. Writable is a writable property. Okay. Commandable is a priority array. So when you see command in BACnet, that means we can command it to like on at priority 8, on at priority 14. If you don't remember what priority arrays are in 449, we covered them in great detail. Writable is you are just writing a value. There is no priority array. I want to be very clear on that. Okay. So let's keep going here and let's go and let's start to look at this. So right here, we have our BVs, we have our AVs, etc. So what would happen at this point? You have your points list. You know this is an MSTP field bus. So if you showed up out on the job site, and I'm just going to check, make sure no questions are coming in here, see if anyone's asking stuff, because sometimes they don't show up for whatever reason. And I just want to make sure I'm covering any questions you all may have if you have any. All right. I'm not seeing any, so we're good. Remember, this is a live interaction. If anything's unclear, please interact in the chat. It really beats just me talking to a reflection of myself on the screen. I see several of y'all are in here, so I appreciate that. Okay, so you're out in the field. You go to a job site and you find out they have this ABB drive. The first thing you need to do, ideally in the specification or in your submittals or in the MEP set somewhere, it's going to say controls contractor or div 23 contractor to integrate. And you're like, okay, great. I got to integrate. You're going to understand the sequence and you're going like my personal stance is here, by the way, on integrations to things like speed drives and whatnot, hardwire to them for control, integrate to them for monitoring. That's my 2 cents on how you should do things, but that's the world according to Phil. So first thing you're going to do, you're going to go and get the ABB drive model number. In this case, we see it's an ACH 580. We're going to go and verify that it actually has the BACnet integration card in it because some systems will come with an integration card, some will not. And if you look up the model number, it may say it supports BACnet, but that is if it has an integration card. Next thing up, you want to make sure that it is configured. Remember, 99.6K and 38.4K are the baud rates that the standards required to support. So typically, I recommend we do a 38.4K baud rate because pretty much every BAS BACnet device is going to support that. Can you go faster? Absolutely, you can go faster. But if you have multiple third-party BACnet devices, the likelihood that one of them doesn't support 76.8 or 115, that is possible. It's less likely nowadays, but back when I started in the field, it was very likely. So you want to get that 38.4 baud rate. You go into the ABB panel, you make sure it's set, you punch it in there, you punch in its MAC address, you punch in the baud rate, you punch in the device ID if you're configuring that, or you communicate that to the startup person. You document it, and then what you do is you make sure that your wiring is connected. So if you're using black for negative and red for positive, then you want to make sure that that is being done at the controller as well. And you want to make sure that the wiring to the MSTP drive, one is in separate EMT from the power cables, so you don't have interference. But is also, you want to make sure that it's done in a way that it adheres to the RS-485 standard in length, device node count, things of that nature. Assuming baud rate, device ID is set up, assuming your RS-485 standard wiring distance and node count is set up, then it is simply a matter at this point of going in and executing a whois, which is quite simply a discovery of the device. So you should find the device, and when the device comes up, add it to your tree, and then do a I have object discovery, and you'll discover your sub objects and you'll map in all your points. And this is where you'll have to go and you'll have to potentially write because you'll notice like BO output relay 1, since that's a configurable relay, you don't necessarily know what's wired to that. So you may have to add a description, and that is where that writable aspect comes in. You discover these points. You've got these points mapped in. You map them into your BAS, and Bob's your uncle. You're done with the integration. That is how integrations work. Now, where do things fall apart? In my experience, the big 3 areas with MSTP that things fall apart, and please in the comments, let me know if I'm missing an area that you think systems fall apart. But in my experience, the big 3 areas that they fall apart: improper wiring. Maybe they've got polarity switched. Maybe they've got a grounding issue. Maybe they've violated the RS-485 standard in length, device node count, or segments. That's the first one. Baud rate. Maybe they have a baud rate that is mismatched from your baud rate. Maybe they're doing 9.6 and you're doing 38.4. Next is a duplicate BACnet MAC address or device ID. So those right there are potential issues. If you check those three things and all that's set and you got the BACnet card, you should 99% of the time be able to discover the device, barring some sort of other failure. So I'll pause, see if any questions. Hopefully this helped give you a perspective of BACnet integrations. Hopefully this made the whole topic a little bit more digestible, a little bit more understandable. I think we'll look at BACnet IP in the near future. Sometimes, and folks, you have to forgive me, I say, hey, and next Wednesday we'll look at this, and then I forget that I said that, and then I have to come up with a topic, and I'm like, oh, let's do this. So I will try my damnedest to remember that we are going to do BACnet IP next Wednesday, and that we're going to have some IP fundamentals. We're going to go through subnets. We're going to go through IPv4. We're going to go through like understanding when I say that BACnet IP is a UDP connectionless protocol. It's a layer 4 protocol using BVLCs and BACnet virtual links and all that jazz. I will explain that to you so it makes sense so that then you can understand, oh, that's why we use BBMDs. That's why we use BDTs. That's why UDP port 47808 matters. And if there's a mismatch there, that's what causes the issues. So I'll see if there's any questions in the chat. Let me check. I'm not seeing anything here on LinkedIn, although I do appreciate seeing all of you on here. Thanks so much for being here. I do hope this was helpful to you. And then I don't see anything on the YouTube. I do see a thumbs up on the YouTube. Thank you, Total Tech. I appreciate that. I do appreciate that thumbs up. I'm glad that this was helpful. Hopefully you are leaving this less confused about BACnet, especially BACnet MSTP integrations. If you are leaving more confused after this, this is your opportunity to go in the chat and be like, Phil, I understood BACnet MSTP integrations, and now I'm completely lost and confused. This would be a great time for you to say that. I don't think you're going to be confused. I'd like to think I'm pretty good at teaching this, but if I lost you somehow, please, I'll hang around for just a little bit. As always, everything's going to be available at podcast.smartbuildingsacademy.com/451. This will be up in about the next hour and a half, give or take. But it'll be available there. And as always, if you found this valuable, please consider subscribing on YouTube, hitting the notification bell. That grows the reach of this podcast, enables us to go and really share some more information. Also, if you're on Facebook or LinkedIn, please just hit share this with your network. That would mean the world to us. And if you're listening on Spotify or iTunes and you feel like we've earned it, I really would appreciate a 5-star review. Thank you so much. So that being said, I'll chill here, just see if there's any questions at all. I'm getting a private question in LinkedIn, said I got a BACnet status flag question for me. So yeah, let's see. Your teaching skills are awesome. Looking forward to all the episodes as long as they are done by you. Hey, I'll tell you though, I'm not even going to try to pronounce your name, but our instructors are way better than me. They're like way better. I hope to get them on YouTube again. They've just been so freaking busy teaching, but they do, in my opinion, way better presentations than I do. So with that, let's do this. Nathan, have I noticed more issues at MSTP or IP integrations? Completely IP integrations. Because here's the deal. So IP integrations, there's a lot of factors that are out of your control. So with MSTP, you're dealing with a very isolated environment. Either someone cut the wire, someone introduced a device that has a bad MSTP baud rate, a bad MAC address, but most of the issues short of a wire being cut, those are addressed on startup. When you introduce IP to the mix, as we'll learn on our next episode, IP is where things can get really messy because all it takes, and I experienced this, there was a data center I was working with and I got called in to troubleshoot it. And their server kept going offline at night and they couldn't figure out why. And what ended up happening was an IT person added a SQL database to the same VLAN as the BAS VLAN and the same physical LAN. So across the trunk port at night, when the SQL database backup would happen, it was such a big backup that it actually hit the quality of service buffer. And so quality of service is basically a tag that goes on your data field. And your tag, what happens when it goes on that IP packet, that tag is going to say, this is higher priority data. So you have a buffer coming out of the switch. And nowadays you don't run into this as much because we have bigger buffers. We're using giga or 10 gig ports, but back then it was much smaller ports coming out. So what happened was the quality of service tag was higher on the SQL data, and BAS data still to this day, I'm not aware of any BAS data that has quality of service tags on it. So this data was being dropped as soon as that SQL database. You see this a lot in hospitals. You see this a lot in data centers, hospitals where they're using like 8K or 12K cameras for remote surgery. You'll see if they're on the same subnet as the building automation data, you can see quality of service interferences. So you have that, maybe an ACL, an access control list on a firewall, especially with some of these smart firewalls now. Maybe that triggers and it blocks your data. Maybe they're using DHCP to go and assign IP addresses to devices. And for whatever reason, you have a power cycle, and this wasn't a sticky DHCP address. This was just pulling from a pool. And all of a sudden, and you're not using domain name services. So when the server or the network resets and the device resets, you actually lose a device and stuff goes down. So I see more difficulties on IP integrations because there's more areas that can interfere with your networks that are outside of your purview and direct control. So hopefully that helps, Nathan. Well, folks, those are some great questions. I'm going to try to see. There, I'm just responding to that person. And by the way, folks, if you ever want to go and ask a question, you're more than welcome to message me directly on LinkedIn, message us directly on YouTube, hit us up in our contact form. I love questions. They inspire future content. So you don't have to call something out. I've said a lot of stupid stuff. Those of you, there was this time period where I kept saying SQL instead of structured query language. I kept calling it sequential query language. And the thing is, I have a master's degree in like computer stuff, but I would still call it wrong. So never be afraid of like saying something wrong. The thing is, I like to say this and I feel it's very true. There are some people who try to like get their ego stroked by their sense of knowledge. But really, in this field, I can tell you the most successful people in building automation are the people who know how to Google and research. There is no point memorizing everything in ASHRAE standard 135 or in standard 62.1, right? For outdoor air, for proper oxygen to spaces, right? No point memorizing that. Just learn to Google and research, because those are the people who are going to be able to find the answers quickly and really like just make themselves very valuable to their team, to their customers, etc. So Nathan, thank you. I appreciate that. It was great seeing you in here. I hope oh, you're Nathan Miller. Oh, I hope the courses are going well for you. So it's good to see our customers in here. So I couldn't see your face because the stream icon was blocking it. Well, hey, thanks so much, everybody. You all are awesome. I love doing this. I can't wait to get into some more really cool topics. If you have an idea for a topic, definitely let us know. Like, send us messages, send us carrier pigeons, let us know what you'd like us to cover. We're here to educate you. We're here to really grow your capabilities. And until next Monday, which I have no clue what I'm going to be talking about on Monday. Until next Monday, I'll see y'all. Oh, and if you don't know what you don't know about your skills, I encourage you, go to our website, either under podcast.smartbuildingsacademy.com/451. That'll be up in about an hour, or just go to our main website and check out our free online skill assessment. It will help you pinpoint exactly what you or your teams do not know. It is not a test. It's just a snapshot in time to help you understand maybe where you need to grow a little bit in your skills. Thank you all. I appreciate you all. And I look forward to seeing you next Monday. Take care. Stay awesome.